Welcome back to another interesting video on my channel. Today we'll be talking about embedded systems, and before that, please don't forget to like, share and subscribe my channel, and do comment below. Let's get started. An embedded system is a computer system which is a combination of computer processors, computer memory and input and output peripheral devices, which has a dedicated function with a larger mechanical or electrical system. It is embedded as a part of a complete device, often including electrical or electric hardware and mechanical parts. Because an embedded system typically controls physical operations of the machine that it is embedded within, it often has real-time computing constraints. Embedded systems control many devices in common use today. In 2009, it was estimated that 98% of all microprocessors manufactured were used in embedded systems. Modern embedded systems are often based on microcontrollers, but ordinary microprocessors are also common, especially in more complex systems. In either case, the processor used may be types ranging from general purpose to those specialized in a certain class of computations, or even custom designed for the application at hand. A common standard class of dedicated processors is the digital signal processor DSP. Since the embedded system is dedicated to specific tasks, design engineers can optimize it to reduce the size and cost of the product and increase the reliability and performance. Some embedded systems are mass produced, benefiting the economies and of scale. Embedded systems range from portable devices such as digital watches and MP3 players to large stationary devices such as traffic light controllers, programmable logic controllers, and large-scale complex systems like hybrid vehicles, medical imaging systems, and avionics. Complexity varies from low with a single microcontroller chip to very high multiple unit peripheral and networks mounted inside a large equipment rack. One of the first recognizably modern embedded system was the Apollo Guidance Computer developed ca. in 1965 by Charles Stark Draper at the MIT Instrumentation Laboratory. At the project's inspection, the Apollo Guidance Computer was considered the riskiest item in the Apollo project as it employed the then newly developed monolithic integrated circuits to reduce the computer size and weight. An early mass-produced embedded system was the Autonetics D-17 guidance computer for the Minuteman missile, released in 1961. When the Minuteman II went into production in 1966, the D-17 was replaced with a new computer that represented the first high-volume use of integral circuits. Since these early applications in 1960s, embedded systems have come down in price. There has been a dramatic rise in processing power and functionality. An early microprocessor, the Intel 4004, was designed for calculators and other small systems but still required external memory and support chips. By early 1980s, memory, input and output systems components had been integrated into the same chip as the processor formed a microcontroller. Microcontrollers find applications where a general-purpose computer would be too costly. As the cost of microprocessors and microcontrollers fell, the prevalence of embedded systems increased. Today, a comparatively low-cost microcontroller may be programmed to fulfill the same role as a large number of separate components. With microcontrollers, it became feasible to replace, even in consumer products, expensive knob-based analog components such as potentiometer, and variable capacitors with up or down buttons or knobs read out by a microprocessor. Although in this content, an embedded system is usually more complex than a traditional solution, most of the complexity is contained within the microcontrollers itself. Very few additional components may be needed, and most of the design effort is in the software. Software prototype and test can be quicker compared with the design and construction of a new circuit not using an embedded system processor. Peripherals. Embedded systems talk with the outside world via peripherals such as System Communication Interfaces (SCI), Synchronous Serial Communication Interface, enhanced by Synchronous Serial Interface, Universal Serial Bus (USB), multimedia cards, SD card, compact flash, etc. Networks, Ethernet, LANworks, etc. Field buses, CAN bus, LIN bus, Profibus, etc. Timers, capture and time processing units. Discrete I/O, general purpose input output, GPIO. Analog to digital, digital to analog, ADC, DAC. Debugging, JTAG, ISP, BDM port, BITM, and DB9 ports.